See how many we can get this time.
You have more?
I did get one.
Right, that's three. That's three that we're giving.
Okay, 30 seconds.
Three.
30 more seconds.
Uh-oh. Go another room here.
Honestly, gotta make this work. Come on.
All right.
Come on, dude.
Need more N2
20
maybe.
more seconds.
20.
30 or 20? There are two different numbers there.
17.
Oh, come on.
15.
I can't make it work fast.
You can do this, Fox.
I am doing this.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Seven. I'll do a count, Fox. Move on to the next one.
Okay, next one.
Bottle with fire.
Bottle with fire. All right, let's see what we have here. So here we have a 5-gallon water jug, but we're not going to add water to it. We're going to add something else. We need to add a fuel. Where's our fuel? Here it is. All right, so combustion, basically, we need three things. We need fuel, which is going to burn. We need an oxidizer, or oxygen, to help fuel that burn. And then we're also going to need a source of heat. So for this one, we're going to use fire as our source. How many do we have?
1, 2, 3, 4. We had 6. One no longer with us.
Oh, perfect. All right, so you're going to see why this is called a whoosh bottle in a few seconds. So we're going to have to add our heat. So we have fuel, which we added to the bottle. Let's add a little bit more. We have oxygen. Here's our heat source. When we bring all three of those things together, we get
Fire.
whoosh. All right, there we go. So that's our whoosh bottle.
Let's give you some
6,
seconds. We got some space in here.
5.
Break here.
It's kind of rough.
Right, what's next?
The next one's
Oh, that's you. Okay, have fun.
Alright, so some of you saw this demo before, right? We've got these two spheres, and the outside of this one, we've got some red dusty stuff, our iron oxide, another key ingredient for a combustion reaction. On this one, we've got that aluminum foil, that is going to be our fuel. We need heat, right? So we're going to use friction for this heat, and we get a spark. But we have 38 seconds. Let's see how many we can get in 38 seconds. You're getting tired.
Yeah, right.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
There we go. All right, back to the liquid nitrogen. Wow, I can smell that. That's a good burn. All right, so we're going to try to launch as many corks as we can, because as the nitrogen heats up, it is expanding about 700 times, which means we're not going to be able to contain it very well. So let's see if these corks can actually contain our nitrogen. Go. There's one. There you go. 2. There you go. 3. Get a little bit more. Okay, here we go. This is good work. Ah! It's cold. Ah.
It's so scary. I knew we were ready for us on stage. 16 seconds, Fox. Come on. Alright, 20 seconds, Fox. Come on. Next one is balloon top cork.
Top cork, okay.
Oh no, wait. I have it, man.
Need a balloon?
I need a balloon.
Uh-oh.
No, it's not a balloon, not a balloon.
I have a glove. I have a balloon.
You have a balloon?
And one of these.
No.
It's like a work.
That's not a balloon.
A balloon.
Don't worry.
Okay.
30 seconds.
Oh, this is going to be scary.
It's not going to go when we want it to. Wait, I have a balloon here, Fox. What?
Okay, we're going to have to find something else to do.
Oh, yeah, I know what I mean. Keep talking about Fox ad lib.
Alright, so since liquid nitrogen is pretty cold, right? We're going to be using it for other demonstrations as we go forward, just to point out how cold it is. Negative 320 degrees Fahrenheit. That is about 400 degrees colder than this room is right now. Which means it cannot stay that cold, so we've actually been watching it heat up and boil, which is why those corks were able to fly away. The pressure on the inside increases, and it is now time for the next
Start on the
round.
podium. I'll get this inside.
Like a podium. Okay, cool. So we're going to move on to another one using combustion again. So that means we need this powder called lycopodium. Now lycopodium is extremely flammable, but if I try to burn it like this in this dish, we have a problem. We need an oxidizer. There is oxygen in the air, but we're not going to do enough to each one of these greens. So we're going to have to spread it out if we want that to explode. So one way we can do that is by just pouring it straight through a flame like this. Which is pretty cool.
Cool.
Right, there's our fuel. Okay, cool. But we want to try something a little bigger, because we like to go big. So we're going to take this tube, put this on top of our candle here. So here's our fuel. There's oxygen in the air in this tube. There's our heat source at the bottom. So if we mix these three things, we get
Cool.
a nice big fireball.
Oh, that
What's
one's
happening here?
Uh-oh. Next one pops up. We need, cracker ball.
I don't know, it's just happening.
Next one.
Okay, here we go. First. Alright, so we're going to cool down this racquetball, which is a flexible solid, which means we're going to cause its atoms and molecules to come closer and closer together. And where is our nitrogen? Oh, there it is, perfect. Okay, so we're just going to cool down this racquetball. See if we can bring its atoms and molecules together. And by then, maybe it will no longer be a flexible solid.
We got some seconds here. We got
We've got a few seconds to breathe.
20 seconds to breathe.
20 seconds.
This balloon is not going. Then we need
That's actually really starting to scare me. Okay.
no longer fears.
No longer, okay.
Alright, next one. 5, 3, 2, 1.
One.
Box, that's what it's time to wash your hands.
Oh, okay. Perfect. All right, so we're going to put this aside. I need to wash my hands. It's been a few minutes since I've last washed my hands. So here I have some soapy water. And my favorite thing about soapy water are the bubbles. So bubbles don't have to be just air. Even though we trapped air right here, we can add any other gas. So what gas is that?
This is hydrogen. Who remembers what hydrogen does? There you go.
Okay, perfect, good.
Right? It's a good fuel, so when you heat it up, it gives a nice good combustion reaction. Our Fox has tried that much right there.
Yeah, but that's probably a little too much.
A little too much.
Yeah, you don't want to blow the whole thing up in the dish like that. That would be extremely dangerous.
Alright, so remember, yeah, it'd be dangerous in the dish. You know what's not as dangerous?
This one.
In your hand. Like that. Alright, now we'll do more.
Yeah, let's do more.
Because we got 14 seconds left. We gotta get all this out.
Okay. Squeeze.
I'm squeezing. Your hands are slippery.
Okay. Oh no.
Alright, Martin, you gotta give it to him. Next one is N2 cloud.
Okay, perfect. Alright, so we're gonna have to make a cloud. Everything down?
No, bucket. Okay, in the rain. Alright, so we're making a cloud. Remember from earlier, we need a couple things. We need warm, wet air, so we're gonna add some hot water to it. There we go. Got that nice water vapor rising. The hot air moves up. There's the tiny water molecule. But we want to cool it down, so we're going to use one of our favorite ingredients, as you already know. Liquid nitrogen, right? So we got 17 seconds, Fox.
17? Okay.
Oh, the ball. We got the ball.
Right. And we also have the nitrogen in there for the...
That's perfect. We fluffed that out intentionally. All right. So you ready to check the ball?
I'm going to do this first, and then we'll do the ball.
All right, we're going. 3, 2, 1. And now touch the ball, Fox. All right,
Move the ball down!
Our next demonstration we have is our balloon. All right. So inside this balloon, we have that same fuel from earlier. This is our hydrogen gas.
Okay.
Right? Hydrogen loves to react with heat and oxygen to give us a big explosion. We're going to launch this one with Fox. Or what are you doing, Fox?
I'm getting to...
We're going to get that close to this, Fox. Is that a good idea? We're going to get that close to it when it goes off?
No.
No, we need to be a safe distance. So let's use a flamethrower. That's totally normal. We got that here in the museum.
I should stand over here then.
No.